Hi, and welcome to this month's Power Hour session. I'll be your presenter, Urbano Espinoza. I'm an application engineer and instructor with NextRev. I've been working with PTC CAD since Pro Engineer Wildfire 4.0, so since about 2008. And my experience includes work in the areas of drafting, computer-aided design, and technical illustration. Now, this session is being presented by NextRev. We're a platinum value added reseller. We sell software on behalf of PTC. We're located in California. We sell PTC Creo as well as other software products developed by PTC. We do training, implementation, and tech support. We cover the West Coast mostly, but we also have customers in other parts of the country as well. So for this session, we'll be talking about building curvature continuous surfaces. And the reason why is that the surfaces you see on your screen will not always be as smooth as you think they are when held up to scrutiny. And so in this session, I'll provide an introduction to several Creo tools that not only create curvature continuous surfaces, but also analyze the quality of the surfaces and their connections. Now, as far as an agenda for the session, I'll start by talking about what curvature continuity is in a general sense, and then we'll specifically talk about how you establish curvature continuity when using boundary blends in your surfaces and using the round feature. That also has curvature continuity control that's not always known about or utilized. I'll talk about using the style tool, also known as the interactive surface design extension, to create curvature continuous surfaces. The ISDX or style tool is an added optional extension that can be purchased with Creo. The reason I'm going to cover it is that it provides a lot of tools that facilitate not just curvature continuous surfaces, but also surfacing in general. And we'll wrap things up by talking about analysis of surfaces. So there's tools in Creo that let you review the surfaces that you're working on and also inspect any incoming imported surfaces that are provided in shared models. Okay, so what is curvature continuity? When we talk about curvature continuity, we often refer to surface continuity. And when we're talking about that, we're talking about the transition between at least two surfaces or curves. All right. And continuity is the mathematical way to indicate how smooth the flow is between two curves or surfaces. Why is this important? The reason is most of our products are not made up of one continuous surface, but rather patches put next to each other. So this could be because of different materials that are utilized or manufacturing constraints. For example, the mouse that you see on the slide, it has sides that have a rubber grip, while the top portions are smooth plastic. And so it's an example of something that we build from pieces. But even though it's built with different pieces and textures, when we hold it in our hands, we want it to feel that it's one product, even though it has a variety of textures. And to do that, we have to make sure that there's no odd bumps or unaligned parts that are higher or lower than one another. Now, in a similar way, when you're actually using surfacing techniques to model your products in CAD, you won't always, or for the most part, be creating one continuous surface. In fact, you'll be stitching together surface patches to make one continuous whole. So an example being this hand scanner that we have here that was created in CAD. If I go to the next slide, you'll see on the right the surfaces and the curves that represent where the different patches that make up the continuous hand grip are. And one more slide will show you one of the patches that is being, one of the surface portions that's being used to link or bridge the top portion of the scanner with the lower grip. Now, when we talk about surface continuity, and in the previous slide, we'll have to make sure that the patch that's being created there is curvature continuous to the top and the lower grip. We actually can refer to at least three, and there's a few more, but we'll cover three here, different types of continuity. All right, and you can think of these three types as steps in a ladder. So each is building on the definition of the last. On the left, we start with positional continuity, or G0 position, and this refers to two surfaces that are connected, that intersect, right? But that there's a hard edge. There's not a level of control in the transition from one to the other. Next, there's tangential or tangent G1 continuity, and this is the next level. It's defined by a circular arc connecting those two surfaces, and so you get a tangential transition, right? And this is a basic fillet in most or round in most solid modeling systems. And even though it's smooth, there is a characteristic break line that you can see, right? A shadow of where the transition from the flat surface to the round is located. And then all the way on the right, which is what we're usually after, is curvature continuity. So it's a little trickier to describe, but technically it occurs when the rate of curvature between two continuous surfaces are the same. And what that means for us is that visually, it is when you begin to not be able to tell when one surface ends and another begins. And in the CAD world, this is the domain of surface-based modeling commands. Now, the primary benefit for curvature continuity is the ability to control smooth reflections across multiple surfaces. So you become able to make sure that you do not see any unwanted bumps or unalignments in your finished product. So you have more control. Okay. This next slide gives a nice visual overview of what I described and what the previous slide began to describe. And the sources from the website core77.com comes from an article called A Periodic Table of Form by Gray Holland. I encourage you to go check that out. In it, the definition of curvature continuity and positional and tangent continuity are not only explained, but also examples and reasons behind using any given continuity in your designs is shown. So here we have examples of transportation design, and then at a product level, we have examples of positional and tangent and curvature being used. Now, why one is chosen over another has to do with visual appeal, right? What kind of visual feel do you want to impart in your design? And there might also be practical reasons as well. But we're gonna, at least as far as creating continuity, we're gonna work on curvature continuity. So I'll go ahead and jump into the demonstration. I'll be using Creo 5.0 to conduct the example. And we'll start by looking at the beginnings of a surface for a mouse, right? Such as the one we saw on the first slide. And what I'll do is I'll use a boundary blend to create a surface that links this top portion with the one on the side. So let's go ahead and do that. Now, for a boundary blend, you'll need some boundaries, and I have these two surface edges that I'll use, but I also want to close things off with a third and fourth boundary made up of curves. So let's go ahead and do that. I'll do curve through points, and I'll pick 2 points on one end and finish that. And then I'll go ahead and pick 2 points on the other end and finish my fourth boundary. Now, there's these icons that appear at the end of your curve. Those are your end conditions, right? And if I right click, they give you the continuity that you're going to be expecting, and the default's free, like we saw, tangent and curvature continuous. I'm going to leave it at the default of free for now, and I'll build my boundary blend. So I'll go ahead and select the surface edge, the first one, and then the second, and then going right clicking and selecting second direction, I can pick the two curves that I just created, and I'll go ahead and finish that up. Now this shows you that we have a boundary blend that has positional continuity with the two surfaces, right? And if we want to adjust it, we'll edit that boundary, and there is actually boundary conditions, right? Same icon as you saw with the curve. If you right click, you also have the option there. So, let's try to impose a curvature continuous boundary. And what that's going to do is it's going to tell Creo this boundary blend all along that boundary, that edge there, that connection to the top surface, I want it to be curvature continuous. So we'll go ahead and try to do that. Now, as soon as we do try, the preview disappears, and that's usually a sign that something went wrong. And you can verify that by clicking on these classes icon, and you'll see that it's telling us the boundary curves are not tangent to the tangent surface at highlighted points. It's a small little icon that highlights where that is. Let's cancel out. What that's telling us is that Creo cannot make this boundary blend curvature continuous, because when it reaches the end, the curve here has to be curvature continuous as well. So let's go back and make sure that we do that. Okay, so we have a failed feature here. All we got to do is go back to the curves and click on their boundary conditions and set those to curvature continuous. Now, when I set those to curvature continuous, I have to select the edge I want them to be curvature continuous to. You can also go to the end conditions tab here and then select the edge that you wanted to be curvature continuous with. Now you see that I selected the that vertical edge. That just goes to show that it does not have to be in contact with the edge to be aligned with it, but in this case we do want that to be. And I'll click to make sure that I'm picking that other endpoint. And now you see how it imposes curvature continuity. It adjusts the shape of the curve to make sure that as you flow from the curve into the edge of that surface, it's a smooth transition. Now, how smooth, how much in the case of these this curve is chosen by the system, by Creo. With a curve that's made up of 2 points like this, you do have the option to go to tweak curve and tweak curve settings, and then you can use these control points to make adjustments, okay, if you need to. And you can even turn on a plot that lets you see that. But we'll go ahead and just click OK. And then we need to do the same with the second boundary curve. So we'll just set that as curvature continuous. Make sure that we pick the edge that we want it to be curvature continuous to. And we'll do that with the second end as well. And then when I do that, you'll notice that now the boundary blend resolves. So let's go and check that out. Now, I set this side as curvature continuous, and then I left this one as a positional with positional continuity. So if we look on the top portion, you can see the reflection, right? But it's hard to see where that transition is. Whereas on this side here, you see the break line clearly, or at least with more clarity than on the right. So we'll set that to curvature continuous as well, and then that kind of blurs it a lot more. So in that way you can set curvature continuity in your boundary blends. Now this isn't just with boundary blends that put two patches together and then bounded by curves. What if we have a case such as this one? Now I have a projected sketch here. I'm going to go ahead and trim that out. Use that projected sketch to trim a hole in the top portion of the surface. So let's go ahead and select trim, and then we'll use let's see here, we'll select the trim quilt there, and then the trimming object will be our curves there. Okay, so now we have a patch there that's open. Let's go ahead and hide those curves, and we'll replace that with a boundary blend. Okay, so go in the second direction. Okay, and we'll leave those as free. And then if I move the reflection, you can make out exactly where that patch is, right? But if we go back and ensure or impose curvature continuity on all bounding sides, When we go back, it's hard to distinguish where that patch is. So that's an example of a curvature continuity using boundary blend surfacing command. Before I go on to the ISDX example, I did want to show you how you can create curvature continuity when you're creating basic rounds in Creo. So I'll select this edge, put a round feature there. And when we finish, let's just, step back and take a look. If I rotate the model, there's that break line that was described in the slide. So very easy to see where the round ends and then the surface begins, the flat surface begins. So let's edit the definition and I'll show you where you can impose some level of curvature continuity. If you go to sets and you see there's this drop down menu right at the top, there's actually different options, and the third one down is C2 continuous. And what it does is it says, all right, to achieve this, it gives you another option or parameter to adjust, if you will. And this one keeps it from being a constant radius, right? It becomes a parabolic or elliptical practically. And the idea now is that with this added option, you can start really blending this fillet. Let's go ahead and stretch it out a little bit, and then with the right level of adjustment, when we finish, it gets harder and harder to see where that break line is. Okay, and of course the result is not a constant radius. Okay, so next up, let's take a look at creating curvature continuous surfaces using the ISDX tool. So we'll be actually looking at a hand scanner, like the one that was seen in the slide. Okay, so here's the example there. And if you see right away, I can highlight the surface patch that provides the bridge between the lower piece, the grip, and the top part. Even though when we deselect, it's one continuous surface, at least for all practical purposes. So let's go ahead and close these up. Okay, so I'm going to open the model in a state where it's at the point where the top surface and then the lower grip surface are already created, and it's just up to us to create the bridging surface patch. And I'm going to do this in the style or ISDX tool. So usually when you start up the style tool, you would press the style button and initiate it. Here we already have a style feature started, so I'll just edit the definition for that. And now we're in another set of commands that create surfaces and curves. So the first step is going to be to create a curve at the grip that will serve as the point where we want the surface to transition into the grip. So I can create an internal plane, and that's just a datum plane created within the style tool, and then give it a distance. In this case, it already saved from my previous creation of a datum internal plane. And I can create a curve by intersect. So I'll go ahead and select that datum plane, and I'll select my grip. So we'll select the surface, and then we'll select that grip. And now I have a curve there at the intersection. All right. Next, I can set an active plane in the ISDX tool, and that just lets me pick a plane that's going to be the sketching plane, if you will. Actually, let me take a second here to give this an appearance that's a little bit more, that makes it easier to see the curves that we're creating. Okay, so there's that curve that we created just a moment ago. And now what I want to do is create a curve on surface. So this is another curve that the ISDX tool allows you to create. That's very convenient. Okay, so basically it lets you essentially sketch spline curves right on top of the surface so that you don't have to create projections. Sometimes creating projections does not give you the result that you want. So we'll go ahead and do that here, and then we'll snap somewhere over here. All right, so right from here I can go to edit definition, and now I can start adjusting this curve. So first thing I'm going to do is set this to be normal to that side plane. Okay, and we'll go to the other end and do the same. Let's just make sure that if we, once we mirror this part, it'll transition smoothly into the other side. And then this middle point I can use to adjust the direction or adjust the position of the curve on the surface. So these two curves that I created will be our boundaries, right? That will serve as the location for the boundaries for the surface that we're going to create. So now, similar to the mouse example, I'm going to create these two other bounding curves. So I'll select the curve. I can do a planar, so it's going to sketch on that active plane, that side plane. And you can snap it to existing points. Okay, so that's one curve. Let's do our other bounding side. Okay, so plane curve, snap it to here, and then go to the other bounding curve. And now we'll create our boundary surface. Now in the ISDX tool, you simply hold control and then work your way around the bounding curves, and it'll go ahead and create the surface. Okay, so you don't have to change directions as you would in base Creo surfacing. Now, let me click OK and show you. So the default is positional, and you see here at the boundary where it goes from the patch that we just created to the grip, we just have a harsh line there. And if you were to hold this scanner in your hand, it would be uncomfortable. So we're going to make sure that we have a smooth transition, and we'll use Curvature Continuity to achieve that. So let's edit this. Now, similar to a regular boundary blend and base surfacing for Creo, you have icons. These are a little different, but it's the same thing. If you right click, you get your options: G0, position, tangent, and curvature. We're going to go straight into curvature. Now, this is convenient in the style tool where, unlike regular Creo, it changes the continuity of the outside bounding curves for you, so you don't have to go back and do it after the fact the way we did in the earlier example for the mouse. I'll do the same thing on the other side, same warning, and it goes ahead and makes the adjustment on the bounding curves. So we'll go ahead and click OK. Now, this is curvature continuous, but let's turn this so that you can look at it from the side. Now, what you'll notice is that Creo went ahead and made it curvature continuous here at the boundary, but then as you move further into the surface patch, you could say that it gave up, or it didn't keep pushing the continuity all the way through. It left this bump in the middle. We can fix that, and the way it's often fixed is by adding some cross curves, right, to help define the shape with more clarity and control. Before I do that though, let's do some trimming here. If I turn it over to the side, you'll see that we still have, parts that we would need to trim. So let's go ahead and do that. We'll go ahead and do a surface trim. We'll select that surface, so quilt collector, and then curve collector. Oh, 1 second here. Let's regenerate. Okay, there we go. So let's trim this surface. We'll trim it with this curve, and then we select what needs to be trimmed away. So now if I rotate, we have the beginnings of a continuous surface. Now we'll do the same thing with the lower portion, the grip here. So the surface we want to trim, the curve we will be using to trim it with, and then the portion that we're trimming away. Alright, so next step is to create a curve that's going to serve as a cross or internal curve for our surface that for the surface that we created. So this will be a free curve, and that just means we can snap it to one bounding curve. So let's make sure it's a free curve. Okay. And we'll snap it to this bottom piece right here, this bottom curve, and then we'll snap it to the top boundary curve as well. Now, let's go right into editing. So conveniently in the style tool as well, if you right click, you can do a surface curvature. So you just pick the surface that you want to make a curvature continuous to. We'll do it on the other end as well. And you see how it changes the shape of the curve to suit that. And then you can adjust how much of a influence it has by pulling on the handle here at the end. Go ahead and click OK. Last step will be to edit that surface and then select the internal collector, and it'll go ahead and do that. And now you'll notice that that bump is gone because that extra curve is now guiding the surface where that bump used to be. We'll go ahead and click OK, and now we have our curvature continuous surface. Now, one more thing before I move on from the style tool is that you have additional ways to manipulate the surface. Maybe you don't want to go to the trouble of creating too many of these cross curves. You can go and edit the you can go to what's called surface edit, right? And then you can build a mesh of sorts. Okay, so here I'll change the columns and rows, and then you can actually use this to push and pull by selecting these mesh lines, and then you can adjust the shape. And it's another way of controlling the result. And once you click OK, you have a style feature, right, that produces a surface for you that's curvature continuous. Now, I'm going to leave this up. We'll come back to it when we're looking at our analysis tools. All right, so what kind of analysis tools do we have? Let me take a look here. Curvature continuous, curvature surfaces. Okay, so the analysis tools I'll show you, they're in the base package. They're not exclusive to ISDX. So we're going back to the regular Creo world. Here we have a block with a top surface, right? And you see it's made up of two patches, and at first glance it looks fine, right? It doesn't look like there's any kind of division there. But if we go to our analysis tab and we go to inspect geometry, the first type of analysis tool I want to show you is the reflection analysis tool, also known as the zebra plot. And you can go ahead and select surface patches, and what the zebra plot is supposed to mimic is the play of light across a surface. So the idea here is that if you were to have a curvature continuous surface, these stripes, these black and white stripes would be continuous. There would be no breaks in them. But if you have a break, right, the equivalent of having a scratch that you could see that's revealed by the play of light, of sunlight, it shows up here as a break in the stripes. Okay, now what kinds of things cause this? Well, it's the surfaces themselves, right? So let's look at what's making up this surface feature at the top, and it's a boundary blend. Let's go ahead and edit the definition. We see that it's made up of these four curves at either end. So if you're troubleshooting, trying to achieve curvature continuity, check the curves or the boundaries that make up your surface feature, right? You can right click on the feature in the model tree, go to information and activate the reference viewer. And then on the left, it gives you what sketches and curves make up that boundary blend. So because it's the break in continuity was running lengthwise, we know that it's one of these sketches like sketch 2. So we'll go ahead and look at that and edit the definition of it. And in the sketch itself, we'll notice that, yeah, it's made up of two curves, and in the middle they're joined by a simple constraint. There's not really any control ensuring that there's either tangency running between those two splines in this case, or maybe arcs. And so the fix for this would be to replace these two segments with one continuous spline, or maybe if you have two arcs, you can impose constraints to make sure that the result is smooth. So you have the reflection plot. You also have what's called porcupine or curvature plot. That's where you select the curves themselves, or in this case an edge, and you can adjust the display of the plot. So what's this plotting? Basically at every point here that you see along the curve, it's imagining there's a radius for that, and it's plotting 1 over r. Now the value is not as important as one value leading into the next, right? So that's why it goes ahead and draws this blue line across all those plotted points, because where you see breaks and steps in that plot is where you know that there's a lack of curvature continuity. So let me go back into the slide to show you. Here's a little summation of what those different the zebra plot and the curvature plots tell you in terms of what kind of continuity you have. So the first one here on the left is positional. If that's what you're seeing, then what that means is that you're going to see the break that we saw in the zebra plot, and then you're also going to see that break in the curvature plot. Now, if you have a tangent connection, you're going to see a step, not a break, in the curvature plot, and you'll see, you know, probably a sharp, even though there's no break in the zebra stripes, you will see a sharp turn, okay, sharp corner. And then on the right, you'll see the smoothest transition, right? So instead of a step here at this curvature plot, you'll see a smooth transition into an increased value. And then in the zebra plot, you'll see a smoother transition into stripes. One other analysis tool is a shaded curvature plot. That's where you can pick the surface, right, and you get some colors, and this spreads out the curvature across the surface by representing high points of curvature with warmer colors, and then lower curvature with cooler colors such as blue and green. So this shows you sometimes you might have curvature continuity at one end, but then as you move away across, you'll see curvature discontinuity. It'll be revealed much more easily with this kind of shaded curvature plot. So let's take a look at an example of something that is curvature continuous. So the same plot, but imagine that we've gone back and made sure that all the boundaries are curvature continuous for that boundary blend. And after doing some of that troubleshooting, if you run the analysis again, we'll start with the reflection plot. No more breaks. And this plot also allows you to increase and decrease the density of the stripes, adjust the spacing, right? Depending on the surface you're examining, you might need to make these changes to make the results clearer to you. You can also save that as well and bring it back later. Let's do the shaded curvature plot. Now you don't see the character. There might be slight breaks, but this is a lot better. And we'll do a curvature plot on the edge. Now you don't see that break that we saw before. One other way to create a curvature plot is to do a sections plot, and that's where you pick the surface, pick a direction, and you can actually do a series of plots across the surface as well. Okay, and then one more analysis tool, and in this case it'll be a surface connections analysis tool. So this tool, you can use it on the models you create, but it's helpful as well for imported surfaces. And if we go to the analysis tool, we go to inspect geometry. At the bottom you'll see connection analysis, and what this does is it allows you to select all the surfaces or just certain portions of them and just overall examine it for different continuity. So if we go to position, we'll notice that all the boundaries for all the surface patches that are identified or this by Creo, at the very least, have positional continuity. Sometimes, well, actually, in this case, we see that it's missing here, so that might be a point to look into. If it doesn't have positional continuity, that means that there's probably a gap, or what it considers a gap, and that would keep it from allowing you to solidify the model, right? Make it a solid. You can adjust the tolerance for what it considers a gap here. If you move up next to tangency, it examines the model, and here we'll see that all these boundaries are at the very minimum tangent, except for that sharp corner here at the bottom. And you work your way up to curvature continuity, and you see now it starts getting a little more specific with identifying boundaries that are not curvature continuous. And you can adjust the tolerance here for what it considers curvature continuous as well. There's one more level called G3 acceleration. That's even smoother, but we're concerning ourselves with curvature continuity, or G2. And before closing this session, let's just go back to the surface we were building earlier and give it an examination. If we go to inspect geometry, use a reflection plot, we can see that the work we've done has helped maintain curvature continuity between, well, all across the surfaces or the resulting surface for the CAD model. Well, I hope that this session has been helpful to give you an introduction to creating curvature continuous surfaces using boundary blends and rounds, and how to do an analysis to make sure that the surfaces you're creating as you go or after the fact are in fact curvature continuous and satisfy your design constraints.